I'm Kelsey. I'm an OpenSciEd teacher and facilitator. This video is for Lesson 7 and Unit 6.2. This is a short lesson, but it's really important for student coherence and moving into the next lesson set. So let's take a look. First, how did we get here? In Lesson 6, we figured out some important things about particles. We figured out that liquids, gases, and solids are all made of particles, but there are different amounts of space in between particles of solids, liquids, and gases. We also figured out that gases and liquids, those particles can move around freely while solids cannot. This left us wondering, if matter cannot enter or exit a closed system, how does a liquid in the system change temperature? Take a look at the lesson at a glance. This is a problematizing lesson. It's one day. There's not much prep, only 10 minutes, and there's no hands-on investigations. Although I did put stars on both of those. I'm going to go into why I did that when we get into the key moments and the materials, tips, and tricks. But we do not require devices, and we do not have any videos for this lesson. So this is a one-day lesson. We have one sense-making loop. This lesson starts by using the driving questions board to take stock of what we figured out and what we still don't know. And then we brainstorm what could cause temperature changes in closed systems. And after that, we model our initial thinking on those causes. From this, we figure out that there are still things we can't explain about what causes liquids and containers to change temperature. But we've got some ideas and some ways we might investigate those ideas. So what we figure out is that since most of the matter does not enter or leave the cup system with a lid, light and heat or cold may interact with the system to cause a temperature change to the liquid inside. And then we're left wondering, how does a cup's surface affect how light warms up a liquid inside the cup? So there's a couple key moments we're going to go through here, starting with the navigation. So this lesson begins by having students summarize what we know and then going back to the driving questions board to articulate what we still don't know. It's really important to utilize the driving questions board throughout the unit. It's going to help the students remember their initial wonderings about the whole phenomenon. It also helps them see that they haven't figured everything out yet, even though it might feel like they have. So you can start the lesson this way. There's also an alternate way to start this with an investigation. So that looks like this. This slide is from the end of Lesson 6, the navigation from Lesson 6. And what this is you show students the data from an investigation using an airtight container. So we have a hot water test and a cold water test in a closed system. And from the data, the students can see that the temperature changes in both tests while the mass doesn't. So you can use that data to drive the thinking forward. You can also do this investigation in the classroom with your students, which I've done it both ways. And I do like doing this with my students. So I have the students use mason jars. We set it up with hot water, cold water. We test temperature before and after and the mass. I like doing this because it seems to really solidify this idea that with closed systems, temperature does still change, and that kind of stumps students and gets them wondering why. So that's why I like to start this lesson with this hands-on investigation. Either way, your students are going to end up from this navigation starting to generate some ideas for what may cause temperature changes, even though matter can't enter or exit the system. So that brings us to the next key moment, which is part 2, where we brainstorm other possible causes of the temperature change. We start with a small group discussion where students are articulating what could be causing these temperature changes. They likely have been discussing these ideas throughout the unit. Might even have some ideas on the initial model way back from Lesson 1, which is great because they're ready to share those things out. So after the small group discussion, we ask students to go public with these ideas, and we make this class list. You're really looking for 2 main ideas here. The one is light. Light is affecting or could be affecting the cup system. And the other is heat or cold getting in or out. You might get other ones. You can throw those on there as well, but you're really looking for those 2 big ideas there. After that, We ask those students, those groups to invest or to brainstorm how we could investigate those ideas and make a list there. So some material management tips and tricks. For the navigation, if you do that alternate activity where you're actually having the students investigate, you're going to be adding time both to your prep and to your class time. So I use mason jars. They're relatively cheap, pretty easy investigation to set up, but it is going to add to your prep time with thermometers and scales. And then add more time to the class, to the lessons, to do it with your students. One more thing about doing this hands-on activity with your students, to take the temperature of the closed system, they're going to have to open it. So you might have students go, hey, wait, we wanted to see if the temperature changed in a closed system, and then we made it an open system. So if you do it this way, you might want to think about factoring in some time to reason through this with your students. Do we think that even though we did open it, do we think that the temperature will still change? And you can kind of work through that with your students. They might say things like, yeah, we know it changes. We felt it change before we opened it, or we've experienced this before. So just think about that, factoring that time in as well. Second tip for this is when you're making these class posters, just keep the ideas general. You don't need to have really detailed ideas here. For example, you don't need students to explain what exactly they think light might be doing or not doing. Just putting on there that we think light might affect it is fine. The second tip here is to have some of these back pocket questions ready. If you have a class that isn't coming up with one or the other big ideas that you need to get to, either the light or the heat or cold, having some questions ready that you could pose to them to get them thinking about that is helpful. So here are some examples. What if the drink was in the dark? Would it still warm up, cool down? What if a cold drink was outside on a cold day? Would it still warm up? What if someone wasn't holding it? Would it still warm up or cool down? Just having those ready might be helpful to keep that discussion going in the direction you need it to go. We do not add any words to the word wall in this lesson. For poster management, we create those 2 posters in part 2. These are not posters that I feel need to go permanently on the wall for the entire rest of the unit. I try and save wall space for things that we've figured out and students can utilize that throughout the unit. But I do keep this poster visible at least for the next few lessons to refer back to, so students remember why we are investigating what we're investigating. And that's it. Moving forward into lesson 8, we will start by investigating light. If your class has done unit 6.1, they have experience with light. We've tested it before, so they're familiar with it. So that's why we choose to investigate that, and you'll see that in the next video.